Let's give this 33 a try. We see we've got 2 pages that are back to back in a book, and they have 132 as a product. Now, product, as soon as I see that, I'm thinking multiplication, but as soon as I see this up front, 2 pages back to back, why don't we do this? Why don't we let x equal the first page, and then the next one, if you flip that page over, it's just going to be one more. So this would be the second page. And then we know this. If I take the product of these two, right, take the product of these, multiply them together, we get 132. So let's write that. X times x plus 1 equals 132. There's a nice little quadratic we can solve. How about x squared plus x equals 132? We'll subtract this 132. X squared plus x minus 132 equals 0. We're going to factor this. Our 2 parentheses, don't forget to equal 0. We're going to start with an x and an x. And now, this 132, let's try this. So 132, we could go with 132 and 1. Those don't differ by 1. Cut in half and double. Now, if I cut this in half, we're going to get 66 and double, 2. It's even. 66 is even. Do it again. 33 and 4. Now, 33 is not even, but I can divide it by 3. So I'll divide by 3 and triple. So this will be 11 and 12. Oh, that's what we want, right? Because they differ by 1. So in our parentheses, let's put in an 11 and a 12. The 132 is negative. These have opposite signs. We'll use that middle plus sign with the bigger product. And the way I've written mine, the inner product is 11x. This is bigger, right? 12x is bigger than 11x. So let's put the plus here, the minus here. Our solutions are going to be 11 and negative 12. But looking back to the beginning, x was the first page. So it's a page number. Can't be negative. So we'll get rid of that negative 12. So we're going to claim now that x is 11, and then right below it, right up here, right below it, is x plus 1, so we'll do that down here. X plus 1 is 11 plus 1 is 12. So the page numbers are 11 and 12. Reading over 34, we see we have 3 consecutive odd integers. So as soon as I see that, I'm going to name these. 3 consecutive odd integers. So how about if we do this? Why don't we let x equal the very first odd integer, and then we've got 2 more, right? So we have the second odd integer. We'll have to name the third odd integer, and we'll do it like this. If x is the first one, the next odd integer is going to be x plus 2. Because odd numbers differ by 2, right? Like if 15 was the first one, the next one would be 15 plus 2 is 17, and then the next one would be 15 plus 4, which would be 19. Oh, not. I've got too many numbers there, so it's just a 4. All right, so what we've got here is that x will be the first odd integer. Add 2, we get the second one. Add 2 more. X plus 2 gives us x plus 4, and that'll be the third odd integer. Now let's read through here and see what it tells us. It says this, 5 times the sum of all 3. So I'm just going to read and write what I read. 5 times, okay, 5 times the sum of all 3. So the sum of all 3, let's just add these up. So it's going to be the first one, x, plus the next one, x plus 2, plus the next one, x plus 4. All right, I've got 5 times the sum of all 3 is equals 66 more than, there's that more than, and we know what to do. Whatever follows more than, that's where we start. So it says more than what? The product, multiplication, of the first and second. So I need to multiply the first and the second. Here's the first and the second. Let's indicate that multiplication, x times x plus 2, and then we're 66 more than this. So we'll add 66. Okay, so there's our equation. So let's see what we can do about solving it. We'll get 5 times, now inside x, and x is 3x. 2 and 4 is a 6, so we're going to get 3x plus 6 equals, over here we'll multiply through, getting x squared plus 2x, and then we got that plus 66. On the left side, let's multiply through by the 5. So we will get 15x plus 30 equals x squared plus 2x plus 66. And now I see this is quadratic, right? I've got a quadratic term. Oh, that's a mess. So I've got a quadratic term. It's on the right side. Let's get everything on the right side, right? We know how to solve them. 0 on one side, everything else on the other. So let's get rid of these. We'll do that by subtracting them, right? They're both positive. So we're going to subtract everything over here. So if we subtract 15x and 30, we're going to be left with 0 equals, and on the right side, x squared, and then 2x minus 15x minus 13x, and then 66 minus 30 is 36. 0 equals this factors. Do you see it? X and x. Oh, what a mess. Okay, let me try that again. Okay. X and x. Now I'm going to use 9 and 4. 9 and 4, I can get a 13. So let's try that 9 and 4. The 36 is positive. They have the same sign. So we get two solutions here. We're going to get 9 and 4. But now follow it all the way back, right? It's a word problem. So follow it all the way back to see what x is. All the way back. Here it is, up at the top. X is the first odd integer. First odd integer. So we come down, look what we've got. I've got a 9, which is odd, but 4 is not an odd integer. So we can scratch that one. So let's get rid of that 4. So what we're going to have now is just this. We've got that x is equal to 9, and then right below it, look at the top here, right below it. So just right below. Take this stuff right here. It's like we're going to do this. We're going to take this business right here. And then what we're going to do is we're going to bring that stuff like down here and write it here. And then we're going to have x plus 2 is 9 plus 2. Right, 9 plus 2, so we get 11. And then we get 9 plus 4, which is 13. So here's our three odd integers, 9, 11, and 13.